All right, I've switched to Streamlabs because OBS is just giving me absolute cancer, but it looks like my camera's working now. So today I wanted to talk about something that is not particularly new. Well, actually, it's not new at all, and it's not like a crazy discovery, but something I kind of came across that I thought was quite cool, and I wanted to talk about. And that is a way to embed, to embed files into your C++ script at compile time, not runtime, compile time, without having to rely on. First of all, hashtag embed, which is a new feature. I'll get into that in a second. There's also standard embed for C++, which is another feature that I will get into. But like before even those features came out, because they are new, you would have to convert the file yourself manually. So for example, here I have, well, I'll show you. Here I got my foo.bin, and if you look at it in a hex editor, you can see I have this data here. And what it encodes is just a number, 100, a float, 2.5, and a string, which is 1J and T01. So like, let's suppose this is some kind of game file, like my HP's here, the character's speed maybe, and then the character's ID. Fair enough. And like, let's say I have this at compile time, and I want to embed it directly into my program so that at runtime, I don't need to open this file and just kind of waste time, right? And there are a few ways to do this, but one way, the kind of the old way, is that you get a script or a program to run over this file and then convert it to something like this. So let's go ahead and create foo dot. Okay, we'll do data dot hpp for instance. So here we're putting it into a header file, and we would have probably like a char array, so like char array, char data, sorry, equals this. And then because it's an array of chars, we'd probably make an array like this, and it would convert these. And then separate these by commas, and like zero exit as well. Let's see if I can get this to work with some near-vim magic. That's visual block mode. I think Q. Let's do, so 0x, and then you kind of just have to do that. Let's play it back. Yeah. So this was kind of what you had to do before. Maybe there's some like even more efficient ways to do it, but like, I mean, why not, right? It takes it takes the bytes of your program, it just puts it into a char array like this, and then you can, in another file, if we make our main, okay, then we can just hashtag include our data dot bin, and then we can just use it. So let's actually see if this compiles here. So I will define a struct first of all to kind of make this more clear. We have our character from our game. I do need a thing there, and we're going to include. Well, okay. I'll also hashtag include iostream and csudint, so I can access std uint32t, which is BI health. I can't remember what this. I don't even know if there is a 32-bit float standard thing, but float should be 32 bits on this system, so this would be our speed, and then a character ID, which would be 8 chars. Read only option is set. Okay, I'm just gonna. Yeah, let me save this as well. And let's get back into this. Subfile. Okay, my cache is messed up apparently. So just abort, delete it. Okay, right. And then we should be able to just read into this struct, right? So I have my data. If you remember, in our file over here, it's just called data. And in fact, I'll also make this const const, just for make it a bit cleaner. And then, I mean, let the compiler know that it's compile time known, and also constant, so it won't change. And yeah, we'll just define an array here, object, character, and we'll just cast, well, we'll cast it to a character pointer and then dereference it. It's an array, so I believe it should decay into a pointer. If it doesn't, then I'll put an address thing there. And then, yeah, we'll just print it. So we'll get the health. Actually, I'll do it like this. We'll get the, yeah, health, right? Health, well, character.health, and a new line, of course. Speed and ID, right? And that should be good to go. So let's go ahead and just compile this. So G++ minus BP is including it, so that's fine. No such file directory. Oh, right, because it doesn't actually exist. It's data wrong file extension there. It should be HTTP. Okay. And save. Taking a second. Okay. And let's see what we get. /main. Cool. So we can see here we have our health, which is 100, speed 105, ID 1JT. So that's fine. And all we did was we encoded our file data here into an array here, and that was good to go. But it's a bit tedious, right? Because I need to either do this manually, as I did, or I need to have some kind of script, some tool that converts my data into a HTTP file that I can include. Which isn't terrible, but like if I want to edit this, right? Like let's say I want to change the character's health to 200. Well, now I need to go ahead and do the whole thing again, the whole process again, which is a bit tedious. And you know, if I have even bigger files, then doing it manually just becomes pretty much impossible. And I need to have a tool that does it. So I mean, like, there's definitely workflows to make it work. Obviously, I'm not going to discredit this. It's been used probably for years and decades. But let's make it a bit more interesting, right? Let's think, is there a way that we can use #include to get our file data into our script automatically without having to run any kind of external tool or do any like hand magic on, well, just writing it out by hand, right? And the answer is yes. So let's go ahead and delete this file because we're not going to need it. We can do anything. We can do everything within our CPP file directly. And so let's go ahead and define this again. So const expr const char data array with an unspecified size. And then we're going to go ahead and #include our binary. Okay, so this is our binary. It contains this, and then we are just including it directly, which should be included as a string. Like, well, like not like a string object, but like each char will just be kind of copy pasted into this file. Because I mean, people have said it all the time. #include is basically just glorified copy paste. So like if the contents of this file was instead like hello world, then this should literally just be hello world, like this, right? But this isn't valid C++ because I do not have strings, right? This should be encapsulated in. Okay, I don't know why I did that. This should be encapsulated inside string literal syntax, right? So, well, there are a few things you could do. First of all, let's go and get our data back. We could go ahead and add strings like so, right? And then this already should pretty much work. If you go ahead and compile, we get a warning. Preserved in literal. Null characters. That's right. Because we do have these zeros. Although I don't know why that's not making it work. Is it a warning? Oh, it's just a warning. Okay. So if you go ahead and compile, run it, and let me just verify this is actually the right exe. So we'll just remove main.exe and then run again, or compile again. Sorry, run again. Yeah. So it works. We do get a warning because it's noticing in all characters, but that should not be a problem. And that's fine, but this is a bit, it's not very safe, because all this is here is 22. And if our floats, for example, just happen to include 22, so let me change this to a 2, for instance, what do we get? Well, first of all, we get a float that is not really what we're going to use, but let's just suppose, right? Then we have an issue here because this is closed. This closes our string early without us wanting to. And it's not because it's meant to be a quotation mark. It just happens that the character, right, which has the hex representation of 22, is also just somewhere in our file. And once again, if you have a file that's like, let me show an example here. Here's another file from an actual game, and if I just do a search for a quotation mark, I can see it shows up in this file almost 2,000 times just by pure chance, just randomly, right? And that's also good, because now if I try to compile this, oh, and by the way, I'll just show you. If I do /main now, you can see it's fine because it has been compiled into our executable. But if I go ahead and recompile, well, actually, I just get errors straight away. Okay, that's cool. And why do I get errors? Because this terminates early, so then this text is just here. This text is just here, just in our script, and that's not valid. That's not valid C++. So to get around this, we need to use something a bit more bulletproof, and for that we are going to use the raw string literal syntax. So well, in general with strings you can have like hello world, and then if I wanted to say add quotation marks here, you can see that my syntax highlighter is already causing issues with this, raising issues with this. We'd have to do like escape characters, right? And then here now we can have quotation marks in our thing. Cool. But there's another way to do this. Instead, we can just add R like this, and then close it as well. I think like that. And this is a raw string literal, which means that everything inside these brackets is not parsed. Like it's not parsed as escape characters. So no escape characters, no quotation marks. Any quotation marks that are in here will just be treated as part of the string and will not end the string early, which is quite useful for some things, but especially useful in our case. And the cool thing is that you can also, because like this is okay, right? But like there's still a chance that this exact sequence will show up randomly in a file. It would be funny if it shows up here somewhere. Or here maybe? No, okay. So in this case it's safe, but if we had a bigger file that was like, say, like PNG data, which is probably like something like image data, which is even more unpredictable, because I mean this is fairly uniform still, then I'm sure that you'd probably come across a situation where you do get these just randomly. So with raw string literals, you can add even more protection. For example, I could add here a dash, and then add another dash here. Or would it be, yeah, sorry, there. And now I have a same raw string literal, but instead of looking for a closing brace and a quotation mark, it will instead look for a closing brace, a dash, and a quotation mark. And I can put anything here, right? So since we're going to embed, the example I'm going to use is CEMBD. And there's another reason for this, because notice that this is 1, 2, 3, 4, 5, 6, 7, 8 characters. And that's important. You'll see why in a second. But then it means I can just go ahead and close it like this. So cool. This is a pretty safe way to do it. If we go ahead and just copy these into my file here. Cool. And then go ahead and also close it in the same fashion. Okay. So yeah, let's just go ahead and run our script again, compile it, sorry, and we can see everything works, right? Cool. And we can even go ahead and replace, let's make this number here 22. I will need to go on overwrite mode, that should give us a number of 34. And then if we compile this, yeah, we got 34. And the rest of the data is fine, no errors. And even though we have a quotation mark here, which is cool. And the only way that this could possibly fail is if somehow this exact sequence of bytes appeared randomly in a file, and I think the odds of this specific thing appearing are just quite astronomically low. So it should be quite safe. And the reason that we do 8, because we could do less, we could do more, but the reason we do 8 is because, at least on a 64-bit system, as Windows 11 should be, byte alignment is quite important. Because like if this was just like 3 characters, right? Then you can see here that this integer is no longer 4 byte aligned, nor is it 8 byte aligned. So it's kind of wonky. And to my understanding, computers are able to much more efficiently parse files if they do actually follow alignment. Because I guess they're just optimized for that. That's an interesting topic to learn more about, but I have my surface level understanding for now, and that tells me that really we should try to keep things aligned. Which is why here you can also see I have my little separators here. That's not just for like, separating 32-bit integers and stuff. Like it's actually so that I can also keep track of alignment when hex editing. So there's a little tip there, and you'll see that, and yeah, you'll see that just in pretty much any file. It's why is there a good example here? I wonder. Yeah, like it's why here for like this message info thing, it extends past what it needs to, because like here's the null terminator. If you know how C strings work, you know that they are null terminated, so they end when you reach a 0 byte. But then the next data starts here. So like, why do we have these 2 bytes here that are just there? Well, for padding. Yeah, that's why. And that's it. Like that's literally it. That's how we can do it. And then if we want to modify our data, we don't need to go ahead and run a tool or anything. We can just change our character's HP to 200 like this, save, and then just compile again. And yeah, it just works because it is accessing the file directly. And the only downside, of course, is that we have this boilerplate in our file, and it means that we can't just like mass import files from foreign sources, because we would still need to add these things. But even then, like I would argue, creating a tool to add these automatically is actually like you'd have to run the tool less times than you would if you were re-exporting to a header file each time. Not to mention it takes less data, like space on your system, which might be important in some cases. So as useless as it may seem, and I mean it will be useless once hashtag embed becomes, well, globally adopted. It still has its uses, I would say, which yeah, it's cool. It's cool, and it's a cool way to access files like compile time. Yeah. So I'm going to make this to do a more extreme example. Let's go ahead and I don't know. Let's go ahead and create like a mock video game format. So we're going to have our size here, which says how many entries we have, and then we have this is one entry, and let's go ahead and add 3 more. We're going to have another character, so this is going to be 2JSP. Shout out if you know what these IDs mean. And we're going to have 3 JTR01. In fact, let's mix things up. Let's go ahead with 8 JSK01. And then we got 100 health on this character. For this character, if I can keep track of where I actually am, let's say this character has 150 health. And let's say this character over here, let's say they have 80 health. Whatever. And then we'll change some speeds as well, because why not? This character should be faster running. So let's make, there's 4. And this character should be a bit slower, let's say. And let's make this 1.75. Okay. Arbitrary. But the important thing is that this data is dynamically sized. I mean, the size is static, but my point is that when we read it, we don't know what the size may be. Because here we have our size here. It's 3 because we have 3 entries. So let's go ahead and see how we would implement that. So now we can't just read straight into a struct unless we, of course, duplicated our data like this. But that will not be very dynamic, accessible, friendly, because then we don't know, okay, but what if there are 10 entries, right? So to do that, to do this properly, we need to, well, we'll keep this as a character, but we're going to read it dynamically, like so. So we'll say, well, we'll store it. Unit 32 to entry count, right, is going to be our data at 0, but we need to cast it, of course. So we'll cast it to a uint32t. I should be using reinterpret cast, but I'm lazy, so I'm just not going to bother right now. For the sake of demonstration, and that should work because that'll take the first entry. If you want to, you can think of this like this, I guess. And it's worth noting that although technically our data starts at the 8th position here. Well, it's small, but this is the 8th position here. This isn't included in the actual string because obviously it's the syntax for the string itself. So this here is still position 0. Hence, data plus 0 gives us this. And then we can do a for loop. So for int or size t I equals 0, I is less than entry count. In which case, I'll actually change this to be no bigger than entry count. I plus plus. Yep, and then that's it. Just do that. Increment that. Make sure we're doing a proper offset. So it should be plus 4. And then the size, which is 12, right? Because one entry is 12 bytes. So we'll do 12 times I. And I believe that should work. And we should get different character stuff here. And then just to make this a bit more visually sensical, I guess, easier to actually read, we'll say, well, we'll put the ID. In fact, let me use std format here for simplicity. We'll say the ID with a health equals health and speed equals this. New line, and we've got character.id, character.hp, character.speed. Yep. And that should be health. Okay. Not loving how that's looking, so I'll go ahead and make this on a new line, delete that, and it'd be hilarious if I have some issues, some errors, but I'm gonna assume this works. Hopefully, maybe. God, this formatting is so messed up. Okay, so let's go ahead and compile. We have an error because SE formats are included, so let's go ahead and just include that. I'm not using print because my compiler doesn't support it right now, which is great. Thank you, GCC. Let's C++ here. I also need to compile with the latest or later C++ version. Cool. So if we do /main, what do we get? So you get the first character, that's fine. Second character didn't seem to do it properly. There's probably some kind of issue with my pointer logic here. Data plus 4, it does skip that. And then plus 12 times I would be 1, right? So it should skip past here. By the way, I've already demonstrated the concept if you want to click off, but I'm just going to try and get this example up for funsies. Data is a char pointer, so that's fine. Adding to it should offset it by 1. That's not an issue. So 12 is correct here as well. I don't know why this isn't working. I'll see if I'll get to print as well the position. So we'll do I think like this. Yeah, that should be right. And then just go ahead and print this offset. So I'll actually store this here. Should probably do like point. I forgot what the thing is for pointer. We'll just do size t, right? Pointer size. Offset equals data plus, well, 4 plus 12 times I. And then we'll just add the offset instead. And then I can print it here. Don't know why it's insisting on going so far forward. My indentation's fine. Okay, recompile. A bit of debuggery going on here. Yeah, so this is hex. So we got 4. Yes, the first one's a 4, that's correct, because it was skipping past the size. So position of 12. Then 10 is 1 0 is 16, which is correct because this starts. The next one starts at position 20 overall, or 28. Sorry, because it's 28 minus 8, which is the size of our prefix. That's 20, so that should be fine. Which makes you wonder why this isn't working. No issues there. This is indeed 12. 16. Oh, sorry. Yeah, the char ID takes up 16. Takes up 8 bytes. My bad. So easy fix. Just change this to 16. Okay. Compile. And there we go. As you can see, we have our file, dynamic size. We got 1JNT, 2JSK, 8JSK. That's it. We got all our characters. And then because it's dynamic, if I wanted to edit this, I would just go ahead and copy from here, I think. Yep. And then let's change this character again. So this one, this would be our big boss character. So 500 health, relatively slow speed, like a big tanky brute. And then the character, let's make it Brutus. Brutus. Yeah. So 3 BRT. Oop. 1 BRT even. Okay. Oh boy. I'm mixing up Neovim keybinds with this. Okay. And also we need to change this number here. But notice how I'm not running any tool that will like reprocess my file into a header. I'm just editing I'm just editing my data directly, such that all I need to do is recompile. And what? Unterminated raw string. Did I just overwrite something? I totally did. Okay, my bad. Let me go ahead and no, I'll just add it back. It's fine. Okay, so it's was again. It's closing quotation mark C. No, it's this, then R thing, and then this. Okay. So obviously it's more hassle if you make a mistake like that, but otherwise we just compile and then run it. And then boom, now we have a new character. And if I wanted to shrink the entries, it'll be as simple as just changing this number. Just to kind of show you it's dynamic. So now if I recompile and print again, it just ignores the rest of them. And cool. So yeah, it's honestly, if I were to set up some kind of system where for some reason I wanted my data to be stored in a binary file, and then accessed at runtime, compile time, I would do this. Because maybe you have some like, I don't know, like tool chain set up, right? That makes for like editing files in some GUI, and you want to store it to binary format, and then yeah, I guess. And then that's fairly straightforward. The only downside is you have to make sure you have this and this. So hey, I don't know. I mean, either way, like I did talk about this in the C++ Discord server, and the consensus was, why would you do that anyway? Um, oh yeah, that's right. I talked about it with Capilani in the JoJo's modding Discord server. Like, just generally speaking, embedding files into your exe, because like this will embed it into your executable. It's not that great because it means you have a bloated exe and can even be. I don't know if it's slower, but like definitely it's just not like loading like a big game loading files at runtime and then just like putting that into the loading times is better than stuffing it all into your exe because either way you're gonna need to load the stuff. Like, yeah, I don't know. I don't know what you would even embed files for. Maybe some like configuration stuff, configuration stuff, settings. But in that case, hatching embed will make that easier. Whatever. At this point I'm just kind of rattling. But hopefully that was interesting. If you want to read into a bit more detail, I have this post over here. Yeah, subscribe for more C++ and programming videos.